a United Airlines Boeing 777 on a long-distance flight. It is one of the more than 9,000 passenger jets that Boeing has built in recent decades. All the large airlines include the aircraft from the Seattle, Washington manufacturer in their fleets. According to statistics, Boeing has built so many aircraft that worldwide more than 800 Boeing jets are permanently in the air. This means that every 5 seconds, a jet from Seattle is somewhere taking off or touching down. The Boeing fleet presented in this film is composed of the B707 for medium-haul routes and long-distance flights, the only tri-jet in the Boeing family, the B727, the short-haul jet, B737, the B747 jumbo jet, the largest passenger aircraft in the world, the short and medium-haul jet, B757, the wide-body long-distance twin jet, B767, and the latest model of the fleet, the B777, also called 777, the largest twin jet ever built. In July 1954, the rollout of the Model 367-80, the Dash 80, marked the beginning of the history of Boeing passenger jets. During the Second World War, Boeing had mainly specialized in building bombers, and it was now seeking a way into the civil aviation market. Boeing had gained a lot of experience in jet propulsion through its B-47 and B-52 bombers. Boeing wanted to utilize the high reliability, as well as the speed and the economic efficiency of the Dash 80's jet propulsion for civil aviation. The Dash 80, which is propelled by 4 jet engines, each with 10,000 pounds of thrust, has an operating altitude of 30,000 feet. It cruises at a speed of 485 nautical miles per hour, and is thus almost twice as fast as the propeller-driven aircraft of the time. Many instruments and operating devices in the cockpit, as well as its shape with the backswept wings, still remind us of the B-52. It was the US Air Force, not the airlines, who first discovered the advantages of jet propulsion. At the end of 1954, the US Air Force ordered 29 -80s to be converted into refueling aircraft. They were to be used to refuel the strategic long-distance B-52 bombers in the air, because the propeller-driven refueling aircraft, the Stratoliners, were proving too slow. This resulted in the -80 becoming the B717. A specialist monitors the in-flight refueling and manually controls the refueling adapter from the specially opened rear window. These maneuvers also convinced the airlines of the advantages of jet propulsion, and Boeing received its first orders for a civil version of the B717. In November 1955, American Airlines became the first customer for the new passenger jet. The -80 became the B707. Equipped with more powerful engines and a longer fuselage, it can carry 180 passengers over an operating range of 2,600 nautical miles. At a later stage, a 200 and a 300 version were developed on the basis of the first model. With a range of 3,700 nautical miles, the 707-300 flies the North Atlantic route between Europe and the USA non-stop. In 1959, a shorter long-distance version, the 720B, was developed. In March 1982, the last 707 left the factory. By then, more than 1,000 707s and 720Bs had been delivered. Some of them are still in operation. An important model in the Boeing fleet is the 727. At the end of the 50s, Boeing's engineers presented plans for a short and medium-haul jet. However, the project was postponed as the financial risks could not be assessed. Eventually, in February 1963, the new B727 took off on its maiden flight. For economic reasons, the 727 was a trijet with 3 engines mounted at the rear. The aerodynamics included a new system of landing flaps on the leading and the trailing edge of the wings. The rear flaps enlarged the wing area, and the front flaps increased the camber. One eye-catching characteristic is the T-tail, with the rudder mounted relatively high on the tail unit. According to test pilots, the 727 is almost as easy to fly as a small sporting plane, despite its weight of 70 tons. Due to the ingenious aerodynamic structure, banks can be flown with the greatest of ease. The B727 is flown by a cockpit crew of 3. On the right-hand side, behind the co-pilot, a flight engineer is seated at right angles to the direction of flight, in front of an instrument and control panel for the engines and flight systems. Pilots who had previously flown propeller-driven aircraft first had to get used to the high speed of vertical descent and final approach. The 727 requires a landing distance of less than 800 meters. The B727 was manufactured according to the modular principle. The sections prefabricated by Boeing and various subcontractors were delivered to the factory in Renton in Washington for final assembly. As in assembly line production, all individual sections were put together in the assembly building. This method reduced the time of construction to a great extent. The cabin has a width of 3.5 meters and 120 to 140 seats, depending on the configuration. At its original size of 40.6 meters, the 727 was no longer capable of meeting the airline's demand for greater seating capacity. As from 1967, Boeing thus offered a version extended to 46.7 meters, the 727-200, seating up to 190 passengers. In 1979, Boeing started construction of the 727-200 Advantage with more powerful engines and a higher takeoff and landing weight. On all continents, the B727 proved to be a very rugged, safe and reliable aircraft. Due to the short takeoff and landing distances, the 727 can be operated on remote and poorly built runways. The engines mounted quite high on the tail unit have proved to be of inestimable value. Even on gravel surfaces, the 727 can take off and touch down safely, without the jet engines drawing in dust and dirt from the ground. In August 1984, the very last B727 left the factory in Renton. It was the 1,832nd aircraft of this type, a new record in the history of civil aviation. More than 100 airlines worldwide have chosen the 727 as an elegant and economical workhorse on short and medium-haul routes. It is thanks to the 727 that flying has become a means of transport for everyone, and millions of passengers travel efficiently for reasonable prices to their destinations. Numerous B727s are still in operation today. With the B737's first flight in April 1967, Boeing sought to meet the airline's demand for an economical short-haul aircraft. With its length of 28 meters, the 737 is the ideal aircraft for operation on smaller airfields. At 3.5 meters, the 737-100 has the same fuselage diameter as the 727 and seats 100 passengers. With a speed of almost 486 nautical miles per hour, it can fly to destinations 3,000 kilometers away. A typical characteristic of the 737-100 and the 200 version, which was introduced a short time later, are the long engine nacelles protruding from underneath the wings at the front and at the rear. The rudder unit merges smoothly into the fuselage. In the following years, engineers developed a number of so-called derivatives, that's to say, variations on the basic model. The 300 version was introduced in 1984. Its fuselage was extended to 33.4 meters and it was equipped with more powerful engines. The engine nacelles are shorter than those of the 100 and 200 version, but they have a larger and oval-shaped air inlet. The 300 version seats 110 to 150 passengers and has a range of 2,300 nautical miles. In 1988, the Boeing family was extended by the addition of the 737-400. Its fuselage is 3 meters longer than that of the 737-300. This extension increases the seating capacity up to 170 seats. A striking feature of the 400 version is the oval air inlets on the engines. As in the 300 version, the rudder unit no longer merges smoothly into the fuselage, but shows a significant bend in the lower section. The 737-500, which has been part of the Boeing family since 1989, has a fuselage reduced to 31 meters. This version, for 106 to 132 passengers, can be economically operated on medium-haul routes with low passenger numbers. The maximum range of the 500 version amounts to 2,500 nautical miles. With an average consumption of approximately 660 US gallons kerosene per flying hour, the 737-500 is the most economical aircraft in the Boeing fleet. The fuel tanks have a capacity of over 5,300 US gallons of kerosene. Theoretically, the 737-500 could fly for more than 8 hours non-stop. All 737s are flown by 2 pilots. Classic pointer instruments and numerous switches and levers are the dominant features in the cockpit. The next generation of 737s, the 600, 700 and 800 versions, will be equipped with a cockpit fitted with color screens. The first step in this direction was taken with the 400 and 500 versions. In these aircraft, 4 monitors replace a great number of instruments.
Takeoff.
Following the great success of the 727, the 737 has become a real bestseller. Boeing can show more than 2,900 sales to 175 airlines in its order books. The B737 can claim to be the best-selling jet airliner in the world, a record which will probably be unbroken for a very long time to come due to purchase options already available for the 600, 700 and 800 versions.
Good morning, on 550, with taxi.
Blue Air 550, good morning, call you at the end.
Bye.
February the 9th, 1969, a Boeing factory in Everett, Washington, the beginning of a new era in aviation. The largest aircraft ever built by Boeing, the 747, takes off on its first flight. With a fuselage length of more than 70 meters and a wingspan of almost 60 meters, the 747 surpassed all other passenger aircraft built till then. Many eyewitnesses were astonished to see the giant lifting off with the greatest of ease, despite its 320 tons takeoff weight. Because of its enormous size, journalists watching the 747's first flight nicknamed the new aircraft the Jumbo Jet. After its success with the 707 and the 727, Boeing once again had its eye on the long-distance market. However, the 747 was to carry 2 to 3 times as many passengers as the 707. With this jumbo, Boeing wanted to meet the airline's demand for greater seating capacity on lucrative long-distance routes. A new fuselage had to be designed in order to carry 350 to 500 passengers. The wide-body generation was born with the 747's fuselage diameter of 6.13 meters. A typical characteristic are the 2 aisles in the passenger cabin. In October 1970, Boeing introduced the 747-200 with more powerful engines and greater capacity fuel tanks. It can carry 400 passengers on a non-stop flight over more than 5,400 nautical miles. In 1982, the 747-300, with an extended upper deck and a seating capacity of up to 550 passengers, left the factory. The 747's cockpit is equipped with more than 1,000 instruments, switches, buttons, and warning lights. A new inertial navigation system, INS, was developed for long-distance flights. This system, which works with rapidly rotating gyroscopes, gives a permanent indication on 2 displays of the exact position in geographic coordinates. This enables the crew to navigate exactly even without ground radio beacons. The flight engineer sits at a right angle to the flight direction in front of a panel with engine and flight system instruments. His task is to monitor all the displays and control instruments. Despite its enormous size, the 747 is an easy aircraft to fly. At international airports, one easily gets used to the unusual sight of the jumbo. Almost 80 airlines all over the world have added the 747 to their fleets. January 1970, New York to London. Pan Am was the first airline to utilize this aircraft on a scheduled flight. Soon the 747 was operating on many intercontinental routes. To this day, Boeing has built more than 1,100 jumbos and sold them to airlines, leasing companies, and governments all over the world. In summer 1975, Boeing introduced the 747 Special Performance. The 747 SP was developed on the basis of the 747-100. However, the fuselage was reduced by 15 meters and the aircraft was equipped with tanks of higher capacity. This enables the SP to fly higher and faster than the other jumbos and to increase the range. It can carry 330 passengers on a non-stop flight of 6,500 to 7,500 nautical miles. The cruise speed is about Mach 0.92, which equals a ground speed of approximately 540 nautical miles per hour. However, the SP is of no interest for the airlines. The total number sold was a weak 45, and Boeing discontinued production. A bird's eye view of the Boeing factory in Everett, 30 miles north of Seattle. In 1966, Boeing began building this factory for final assembly of the 747, as the production plants in Seattle were already running at full capacity with the assembly of the 707, the 727, and the 737. The dimensions of the factory are as impressive as the dimensions of the jumbo. The gigantic final assembly hall has a volume of over 5 million cubic meters and is thus the largest factory ever built. Each of the 3 gates is as big as a football field. Worldwide, more than 15,000 component suppliers are involved in the B747 program. They manufacture the individual components and systems which are assembled in Everett. Modular construction is the only way to manufacture this giant, as the 747 is composed of more than 6 million parts, of which more than 50% are screws, bolts, and rivets. Put together, all these parts make up a total weight of 150 to 180 tons, according to the model. The fuselage front section is prefabricated in Kansas. The fuselage center section is built in Texas, and the wings are manufactured by Boeing in a factory south of Seattle. For the final assembly, the fuselage center section is connected to the wings and then to the aft fuselage and the fuselage front sections. After the assembly of the tail unit, the aircraft takes its final shape. Now the systems are installed and the engines assembled. The 747 has many impressive components. For example, the 7 tanks in the wings and in the fuselage have a capacity of 50,000 US gallons. This is equivalent to a full tank on 3,800 Volkswagen Golf cars. However, refueling at modern airports doesn't take longer than 30 minutes. In practice, planes only carry the amount actually needed for a flight. The tanks are hardly ever filled to the brim. The individual fuselage sections are moved by huge cranes or tractors. This requires great precision so that individual parts match up. The 747-400, which took off on its maiden flight in April 1988, is the youngest member of the Jumbo family. Characteristic features of the 747-400 are the extended upper deck from the 747-300 and the winglets with a length of 1.8 meters. The total length of 70.66 meters has not been changed since the 747-200. For aerodynamic reasons, the wingspan was extended by 4.8 meters to 64.44 meters. A revolutionary feature of the 747-400 is the cockpit. The all-digital cockpit requires only 2 pilots. 2/3 of the original 1,000 switches and instruments have become redundant. 6 8x8-inch color screens display the relevant flight and systems data. Computers monitor engine performance, exhaust gas temperature and altitude, as well as attitude, speed and fuel consumption, and display the data in the form of graphics or digits when required. From the very beginning, the 747-400 has come with a choice of 3 different types of engine: Pratt & Whitney's turbofan PW4000, General Electric's twin-shaft turbofan CF6 ATC2, and Rolls-Royce's 3-shaft turbofan RW211524. All engines provide an equal takeoff thrust of about 250 kilonewtons per engine. From a commercial point of view, the 400 version has been a great success for Boeing, although it's far more expensive than the 200 version. the Boeing management proudly reports that since 1990, at least one order for the 747-400 has been placed every week. With over 400 orders, the 747-400 is the best-selling jumbo jet ever. Boeing is taking steps to continue its 747 success story. Two new models, the 747-500X and the 747-600X, are to open a new chapter in the history of civil aviation. The new maxi jumbos will go on sale in the first decade of the 21st century. The 500X, with a length of 76 meters, will carry 460 passengers on routes up to 8,500 nautical miles long. The 600X, with a length of 85 meters and a wingspan of 77 meters, seats 550 passengers with a range of 7,500 nautical miles. The B757, which took off on its first flight in February 1982, was designed to offer the airlines a successor to the popular and successful 727-200. However, plans for a 727-300 were turned down, as there were no suitable engines for a trijet at the end of the 70s. So Boeing designed an entirely new aircraft, the so-called 7N7. The 7N7 eventually became the B757. The 757's cabin, with a width of 3.5 meters, is the same as the 727. Compared to its predecessor, the 757's total length was extended by 50 centimeters to 47.3 meters. The aircraft is powered by two turbofan engines, each with a thrust of 180 kilonewtons. They are among the most silent and economical engines ever built by Rolls-Royce and Pratt & Whitney. The cabin seats 186 to 239 passengers. The final assembly of the 757 is completed in Renton. Like the rest of the Boeing family, the 757 is built according to the modular principle. First, the fuselage front section, then the aft fuselage adjoined to the fuselage center section, with the wings having a span of 38 meters. After the assembly of the tail unit, all other systems and the engines are installed. According to Boeing, the 757 consumes 40% less fuel than the 727. This makes the 757 an economical alternative to the trijet, of which production was discontinued in 1984. More than 60 airlines have ordered over 850 757s, 650 of which are already in operation. In Germany, it's mostly charter airlines such as LTU, LTE, and Condor that have chosen the B757. The cockpit crew of two is supported by a digital flight management system. In addition to the classic pointer instruments, the pilot and the co-pilot are kept informed by 4 color screens in the panel in front of them. These display the primary flight and systems data. Condor and other German charter airlines have been operating the B757 on their heavily traveled routes to destinations in the Mediterranean and the Canaries. On charter flights, the airlines offer only a tourist class with 6 seats per row. This configuration accommodates up to 240 passengers. An eye-catching feature of the 757 are the large cockpit windows, offering brilliant visibility and giving the 757 a striking and unique appearance. The B767, which was developed at the same time as the 757, passed its maiden flight in September 1981, 5 months before the smaller 757. The 767, powered by 2 turbofan engines, comes in various versions for medium and long-distance flights. This aircraft is a real wide-body. The cabin, with 2 double aisles and a width of 5 meters, seats 290 passengers. US carriers such as United Airlines, Delta Airlines and Continental fly the North Atlantic route with the 767. The 200 version has a length of 48.4 meters, a height of 15.8 meters and a wingspan of 47.5 meters. The maximum range is 3,840 nautical miles, equaling a route from New York to Frankfurt or from Munich to Nairobi. The B767-300, which was first flown in January 1986, seats up to 330 passengers with a slightly higher range. In December 1986, a long-range version, the 767-300ER, was unveiled, with a seating capacity of 330 and a range of 6,200 nautical miles. Condor's 767-300ER, for example, operates on its 6,000 nautical mile route from Frankfurt to Phuket in Thailand. Other charter airlines as well have chosen the 300ER for non-stop flights from Düsseldorf to the Seychelles or the Maldives in the Indian Ocean. The cockpit of the 767 is similar to that of the 757. Pilots who attain their type rating for one of the two models can fly the other one as well, without requiring further ratings or licenses. Airlines with both models in their fleet can therefore be very flexible in employing their crews.
Check, contact, continue.
400. 300. 200. 100. 50, 40, 30, 20, 10.
The B777, the so-called 777, is the link between the twin-jet 767 and the 747 with its 4 engines. At its rollout in April 1994, Boeing presented the largest twin-jet in the world. Its size can be illustrated by comparing the 777 with the 737-400. The nacelles diameter of 3.5 meters is almost as large as the diameter of the 737's fuselage. The span of the 777's rudder is equivalent to the wingspan of the 737. What is unique about the new twinjet is the way it was designed and produced. The aircraft is a computer product. It was designed on a computer and it is assembled by computer-guided industrial robots. The various engineering departments are permanently linked with all other departments. This reduces the period of development to a great extent, and potential faults and failures can be detected in time and eliminated. In June 1994, the B777 took off on its first flight on schedule. The fuselage has a length of nearly 64 meters and the wings a span of 60.9 meters. The 777 is only a little bit shorter than the 747. The 777-300, with a length of 73.8 meters, will outdo the 747-400 by 3 meters. At present, Boeing only produces the 777-200 with a seating capacity of 305 to 440. With a takeoff weight of 229 tons, the 777 has an operating range of 4,850 nautical miles. The all-digital cockpit no longer requires a flight engineer. Like the 747-400 and the wide-body 767, the aircraft is flown by 2 pilots. The display of the parameters on the large color screens is of fascinating quality. The 777 is still rarely seen at German airports. United Airlines has daily flights with the modern twin jet from Frankfurt to the biggest cities in the USA.
Line up and wait. Final items, please.
Flight attendants, prepare for takeoff, please.
Like the latest generation of Airbuses, the B777 is equipped with electronic fly-by-wire control. Only Boeing have renounced the use of a small side stick. The aircraft is flown with a classic yoke, although there is no direct connection with the control surfaces. The motion of the yoke is electrically transferred to the control surface's servo motor.
So takeoff thrust. Positive flying, gear up.
On transatlantic flights to the USA, a second captain is on board. Over the Atlantic, he takes command in the cockpit. Shortly before arrival, the first captain, who first took off in Frankfurt, takes back control to land the aircraft. The Boeing Aircraft Company has become the largest producer of commercial airplanes in recent decades. Motivated technicians, engineers, and a management that quickly reacts to airlines' demands will make sure that new Boeing aircraft will be an important and dominant factor in international air traffic in the 21st century.